It's pretty amazing when you think about it, right? I mean, all this stuff happening behind the scenes.
Yeah.
Every time we use our phones or buy something online or even just log in,
Oh, yeah.
there's like this whole world of security measures working to protect us. And most of the time,
Right.
we probably don't even notice it. So
Exactly.
like all those times a website makes you enter a second code or your bank flags something as unusual, well, that's often the work of some seriously sophisticated systems
It is.
designed to detect anything that seems out of place. And today, we're going to dive deep into that fascinating world anomaly detection for fraud prevention.
Yeah, and you, our listener, you're probably encountering these systems all the time without even realizing it.
Oh, I bet.
Have you ever gotten that message from Netflix saying you've hit your device limit or
Yeah,
had a payment decline suddenly and then it's cleared after a quick call to the bank?
definitely.
Well, those are often driven by the very principles we're going to be exploring today. We've got a really interesting conversation to unpack here, a detailed look at how these fraud prevention systems are actually designed and built.
Cool.
So get ready to peel back the curtain a bit and understand more about what's going on behind the scenes to keep your digital life safe.
All right, I'm ready.
Great.
Our source today is like getting a peek behind the curtain. It's a deep dive into the thought process and the technical nuts and bolts of building these anomaly detection systems to combat all sorts of online shenanigans.
Yeah.
We're talking about preventing account sharing, stopping fake accounts from popping up, shutting down folks trying to abuse free trials, and of course,
Always a problem.
the never-ending fight against payment fraud.
Right.
So our mission today is to help you really grasp the core concepts of anomaly detection.
Absolutely.
We want to shine a light on the clever technical solutions that make it all work and understand how these systems are constantly evolving to stay ahead of the bad guys. But we're going to do it without getting bogged down in all this super technical jargon. So let's start with the basics. What exactly is anomaly detection when we're talking about protecting things from fraud?
Well, at its core, anomaly detection in this context is all about identifying those things that just don't fit. Identifying those user behaviors that are significantly different from what we typically expect.
Okay.
It's kind of like, imagine a factory with a quality control system that's trying to pick out the single defective product coming off an assembly line full of perfect items.
Gotcha. So you're looking for the outliers, the things that stick out.
Precisely. And when you think about it, most online activity is legitimate, right? Fraud is really the exception. It's the outlier.
That makes sense. So how do you actually go about finding those outliers?
Well, that's where techniques like unsupervised learning come in. They allow us to automatically flag these potentially suspicious outliers. And two common examples of these techniques are isolation forests and autoencoders.
Okay, those sound pretty technical. Can we break those down a bit? What's the main difference between an isolation forest and an autoencoder when you're trying to spot fraud? And when would you choose one over the other?
Absolutely. So let's start with isolation forests. Imagine, picture a really busy airport security checkpoint, right?
Right.
And the system is trying to quickly isolate individuals for closer inspection.
Okay.
If someone's behavior is really out of the ordinary, let's say they're running around like crazy while everyone else is calmly waiting in line.
Yeah.
They're going to get flagged super fast with just a few observations.
Makes sense.
Technically, what isolation forests do is they randomly divide the data. And because anomalies are rare and different, they tend to get isolated in fewer divisions or splits.
Got it.
This makes isolation forests really fast and efficient. They don't need a lot of computing power, which is super important for making those quick decisions in real time.
So it's all about speed and efficiency with isolation forests. What about autoencoders? How do those work?
Autoencoders are a bit more like a really skilled detective trying to meticulously reconstruct a crime scene.
Okay.
They essentially learn what normal user behavior looks like by trying to compress all the important information and then rebuild it from scratch.
Interesting.
If a behavior is unusual or possibly fraudulent, the autoencoder won't be able to reconstruct it accurately. And this error is measured as a high reconstruction error.
So it's like they're looking for the imperfections in the reconstruction.
Exactly.
Yeah.
And they're particularly good at picking up on complex and subtle patterns in the data.
So to recap, isolation forests are like the quick and efficient anomaly spotters, while autoencoders are more like the deep dive analysts that can uncover those more intricate irregularities.
That's a great way to put it.
So in practice, when would you typically choose one over the other?
Well, you'd probably go with isolation forests when you need to make decisions super fast with limited computing resources. Think about those initial checks when you're trying to log into an account, for example.
Okay, makes sense.
Autoencoders, on the other hand, would be more useful when you suspect the fraud might involve more complex patterns, that those simpler methods could miss things like sophisticated payment fraud or large networks of fake accounts working together.
Gotcha.
However, they do require more processing power, and as we'll talk about next, they require a careful setup process.
Yeah, you mentioned a careful setup specifically around setting your reconstruction error threshold for those autoencoders. How do you figure out that sweet spot where you're catching the fraudsters without accidentally blocking legitimate users?
Right, that's a crucial balancing act. The key is to use what's called a validation. Set a separate chunk of data that ideally includes both normal user behavior and known examples of fraud.
So it's like a test run for the system before you unleash it on the real world.
Exactly. You feed this validation data into your autoencoder
Hmm.
and see what kind of reconstruction errors it produces for both the normal and the fraudulent cases. And then you analyze how those errors are distributed. By plotting things like ROC curves, which basically help you see how well the system is separating the good from the bad,
Mm-hmm.
or precision recall curves, you can really visualize the trade-off. You're trying to find that threshold for the reconstruction error that lets you catch a large percentage of the actual fraud.
Yeah.
Those are the true positives,
Right.
without also incorrectly flagging too many legitimate users, the false positives.
Okay.
The perfect threshold, it really depends on your specific needs and your risk tolerance.
So it's not a one-size-fits-all situation?
No, not at all.
And I imagine it's not a set it and forget it kind of thing either, right?
Definitely not.
Mm-hmm.
User behavior changes over time, and so do the methods that fraudsters use.
Makes sense.
So it's super important to continuously monitor how well the system is performing in the real world. You need to regularly check and potentially tweak that reconstruction error threshold based on new data and any new patterns you're seeing.
Right.
This helps keep the system effective and minimizes those annoying false alarms.
Now let's shift gears a bit and talk about behavioral analytics. Our source highlights its importance in the fight against fraud. What exactly does that bring to the table?
Behavioral analytics adds a crucial layer of context to anomaly detection. Instead of just looking at a single transaction or login attempt in isolation, it examines the entire sequence of actions a user takes.
Okay.
This includes things like the time of day they usually log in, how often they use the service, their typical location, the unique fingerprint of their device.
Yeah.
Even things like how they interact with the app or website, mouse movements, typing speed.
You can track all that.
In some cases, yes. It's about building a detailed profile of what normal behavior looks like for each user.
So if something deviates significantly from that established pattern, that's when the alarm bells start ringing.
Exactly.
Can you give some specific examples of how these behavioral features can point to potential fraud?
Absolutely.
Hmm.
Let's say someone consistently logs into their account from the same city every morning, but then suddenly they're logging in from a totally different country in the middle of the night.
Yeah, that's suspicious.
Very suspicious. It's a strong indicator that their account might have been compromised.
Right.
Or imagine a user who usually makes a few small purchases each month, but then all of a sudden, they're trying to make a huge high-value transaction from a brand new device they've never used before.
Yeah, that would definitely raise a red flag.
These are the kinds of unusual deviations that behavioral analytics can help uncover. And the real power comes from combining these behavioral insights with the anomaly scores from those algorithms we discussed earlier.
So it's like putting the pieces of the puzzle together.
Exactly. The behavioral data provides the context that makes the anomaly detection much more accurate.
That makes perfect sense. But what about situations where a legitimate user does something out of the ordinary? Let's say they're traveling abroad. How do you prevent the system from mistakenly flagging them as a fraudster?
Right, that's a key challenge, and it requires building in layers of intelligence and really understanding the context. So in your example, the initial anomaly detection might flag that unusual login location, but then the system would apply what we call business logic rules. If this particular user has a history of logging in from all over the place, maybe they travel a lot for work,
Yeah.
the system might recognize this as normal for them and not flag it as suspicious.
So it's like the system learns the individual's habits and quirks over time.
Precisely. You can also incorporate secondary checks. If a potentially risky anomaly is detected, instead of immediately blocking the user, the system could ask them for two-factor authentication, like sending a code to their phone,
Right.
or ask them a security question. And of course, continuously feeding more data into those underlying models, including examples of legitimate travel and other uncommon but valid behaviors. That helps the system get better and better at distinguishing between genuine fraud and just unusual activity.
Now, thinking about the scale of some of these online platforms, our source mentions having to process millions of transactions every single day. How do you even begin to design a system that can handle that much data in real time without completely falling apart?
Building a system like that can handle that kind of volume with super low delays and high accuracy,
Right.
it requires a very carefully designed architecture.
I bet.
And often what they use is something called a microservices architecture.
Okay.
This essentially means that different parts of the system, the part that ingests the data, the part that prepares the data for analysis, the actual anomaly detection model itself,
Mm.
all these pieces operate as independent scalable units.
So if one part needs more power to handle a sudden surge in activity, you can just scale up that specific part?
Exactly. For getting all that transaction data into the system in real time, they often use what's called a message queue system, something like Apache Kafka.
Okay.
Think of it like a super efficient traffic controller, making sure all that data gets where it needs to go reliably. The pre-trained anomaly detection model, which is optimized for speed, will be deployed as its own microservice.
Mm-hmm.
And for those more complex deep learning models, they might even use lightweight versions like TensorFlow Lite to make them run even faster.
Interesting.
The heavy lifting of preparing the data for the model, what we call feature engineering, that's often done in advance using powerful batch processing frameworks like Spark, which can handle massive amounts of data efficiently.
So it's like each part of the system has its own specialized role.
Exactly. And then to manage the huge influx of requests and ensure those quick response times for the real-time fraud scores, they implement caching mechanisms to store frequently accessed information and load balancing to distribute the workload across multiple servers.
It sounds incredibly complex, like a finely tuned engine with all these different parts working together perfectly.
It is.
Which leads to my next question. What are some of the common challenges or pitfalls that you encounter when you have these sophisticated models running in the real world?
Two major challenges that we constantly face are what we call model drift and data imbalance.
Okay.
Model drift, as we touched on earlier, is what happens when the patterns of fraud change over time.
Right.
What might have been really effective at spotting fraudulent activity 6 months ago could be completely useless against the new techniques that fraudsters are using today.
So it's like a constant arms race.
It really is. That's why it's absolutely critical to continuously monitor how well the model is performing and to regularly retrain it using the most up-to-date data.
Makes sense.
Think of it like your spam filter. You have to constantly update it to keep up with the new types of spam.
Right. So what about data imbalance? What exactly does that mean in this context?
Data imbalance is when you have a huge amount of legitimate activity and only a tiny fraction of fraudulent events.
Oh, I see.
This imbalance can really throw off the model's learning. It might become really good at recognizing normal behavior because it sees so much of it, but it could become less sensitive to those rare instances of fraud. It is. But there are several techniques to help mitigate this. One is called oversampling, where you artificially increase the number of fraudulent examples in your training data to give the model more opportunities to learn from them.
Interesting.
There are also specialized anomaly detection frameworks that are designed specifically to handle these outlier situations and techniques like cost-sensitive learning, where you basically tell the model that misclassifying a fraudulent transaction is a much bigger mistake than misclassifying a legitimate one.
So you're weighting the errors differently.
Exactly. And something that's really important is getting feedback from human analysts who review those borderline cases where the model isn't quite sure. This human feedback can dramatically improve the model's accuracy over time.
So even with all the automation, human oversight is still crucial.
It really is.
Now, what happens when, despite all these precautions, your system starts flagging way too many legitimate users as suspicious? You get a spike in false positives. What's the immediate response?
When that happens, the top priority is to figure out why legitimate behavior is being flagged as suspicious.
Okay.
The first step is to really dig into those false positive cases and look for any common patterns or errors in the data that the model might be relying on.
Right.
You also want to immediately check those anomaly detection thresholds. Maybe they've become too strict, perhaps because of a recent model update or a change in the overall data.
Makes sense.
Recalibrating those thresholds using fresh validation data is often necessary. And you also need to investigate whether there's any unusual noise or errors in the data itself, or if there's been a real shift in overall user behavior that's actually legitimate, but the model hasn't caught up with yet.
So you have to consider all those possibilities.
Exactly. Based on what you find, you might need to adjust the model's parameters,
Right.
refine how you're preparing the data, or even bring in additional contextual information to help the model better distinguish between genuine anomalies and actual fraud.
It sounds like a never-ending cycle of monitoring, analyzing, and fine-tuning. especially since those fraudsters are always coming up with new tricks. How do you make sure your fraud prevention system can actually keep pace with those evolving tactics?
Adaptability is absolutely key. The system has to be designed to learn and evolve continuously.
Right.
It goes back to that continuous feedback loop we've been talking about, where
Yeah.
the system is always taking in new data, using it to retrain and reevaluate the models, and monitoring its performance in real time,
Okay.
and integrating the insights and observations from those fraud analysts who are reviewing those flag cases. That's super valuable too.
Right.
Having a modular system design is also crucial. It lets you quickly update specific parts of the system, let's say the model that detects a new type of payment fraud,
Mm-hmm.
without having to rebuild the whole thing from scratch.
Yeah.
It's all about building in resilience and that ability to react quickly to those new emerging threats.
Wow. It really is a constant back and forth, isn't it? This whole world of anomaly detection. It's a fascinating and incredibly complex field, and something that most of us probably don't even think about in our daily online lives. But it's clearly essential. So for you, our listener, we hope this deep dive has given you a better understanding of the intricate world of anomaly detection and how it acts as this vital, multi-layered defense against online fraud.
Absolutely.
And it's clear that it relies on this really clever combination of advanced statistical methods and a deep understanding of how people typically behave online.
Mm,
And to stay ahead in this game, it takes constant innovation and adaptation because those fraudsters, they never stop.
never.
It really makes you think about all those invisible layers of security that are working tirelessly to protect our online interactions. It's amazing.
It is, and it makes you wonder what's next, right?
Mhm.
What kind of future advancements might we see in these anomaly detection systems as technology keeps getting more sophisticated?
Yeah, it's a field that's constantly evolving with tons of exciting possibilities,
Yeah.
so much potential.
Definitely.
Well, we hope this deep dive has given you a solid foundation for understanding this crucial aspect of our digital world.
Absolutely.
Thanks for joining us.
Thanks for having me.